Hi, in this exercise we're going to talk about the least cost path algorithm and analysis. We're going to do a sample problem here. We're going to build a hiking trail in northwest Durham County and Orange County here. You can see I have two vector GIS data layers. The red octagon represents the stopping point that we're going to have. The green square represents the starting point. So what we're going to try to do is build a trail that goes from here all the way up to here, and we have to think of a cost. And what we're going to try to do, since we're building this hiking trail that's going to be family friendly, we want to go up the least amount of slope. When I double click on my cost path algorithm, you're going to see what I have here. Okay? I have some input parameters that I need. Okay, one of the things that I need is a cost matrix, and then another thing that I need, a cost distance matrix, and another thing that I need is a backlink. So before I can even go through and calculate this analysis here, I'm going to have to look at my cost path from my source to my destination, which I already have represented. I'm going to need a cost distance, and then I'm going to need a cost backlink raster here. And before I even do that, I need to calculate the slope here. Okay, and you can see some of the input parameters that I have here. I have my study area here, and this is just I'm going to try to focus this and use this as my mask. I have a DEM that I'm going to use to derive my slope. Okay? And typically my whole thinking is, as I'm at a cell right here, as I move further and further along, I want to go to the next lowest slope. Okay. So if we can try to envision that, if I go from one cell to the next cell to the next cell, as I go from my start to my destination, I want to essentially buy as my cost, the lowest amount of slope. Okay, so as I travel from here to here, I'm going to be going up the least amount of slope. No matter what path I go, I'm going to have the same change of elevation, okay, net change of elevation. But as I do this, I want to accumulate the least amount of slope. Okay, so it's going to be the least possible slope, so I can accommodate, kids and older people or whatever. Okay, in this example here. So the first thing that I'm going to need to do is I'm going to go through and use my spatial analyst tools right here and calculate the slope here. Where are they here? Density, extraction, interpolation, surface. Okay, here they are. Okay, and I'm going to calculate my slope. And since I'm looking at just this study area right here, my input raster is going to be my DEM. Okay, you can see my z factor. I have a big problem with my z factor, and I'm going to make it a really tiny number, 0.0000093, because actually my units for my DEM is going to be in degrees, since I downloaded this from the national map. And this is my conversion factor, so I can just turn it into something that works. Keep in mind, when I calculate the degrees or whatever it's going to be, and I turn this into a cost distance matrix or cost distance raster, it's going to be units multiplied by the resolution. It's really not going to have some inherent value. It's just we're going to look at this slope compared to other slopes that we're going to work with. And then under environments, under my raster analysis, I'm going to make my mask to be my study area. And when I'm set here, I'm going to click OK. I'm going to click OK here. And let's go through and calculate this really quickly. Okay, and this is a pretty small study area here. You can start to see my computer it's a little bit older here, so I can calculate this. So what we're going to get here is a slope map. Okay, and the units, we're going to disregard the units here, but we're going to look at the areas that are high slope areas within my study area, and then low slope areas that are within my study area. And I'm going to give this a minute or two to run, and then we'll calculate the next thing. Okay. Because in order to compute the cost path, I'm going to need to compute a cost distance. Okay, how much is it going to cost for me to go from my starting point to whatever ending point I'm going to select? And then a backlink, which tells me the direction that I'm going to go. One of 8 possible cardinal directions that I'm going to go from one cell, and when I move from that one cell to the next one, which one has the least cost, the lowest slope that I want to go to. It should be done here. Right, and here's my slope map right here. Okay. And I'll get rid of this here. I'm going to remove all my junk here. Remove my... Okay, because as you start to look at this here, let me remove my quad here. Okay, because as we start to look at this here, you can kind of see the direction that I'm going to want to go. Okay, I'm just going to unclick here. Okay, if I go up this way here, you can see the contour lines are really close together, which represents high slope. Okay, if I go up kind of towards this direction here, you can see that it's less of a slope. Okay, if I go across the lake right here, well, that's great because there's absolutely no slope associated with the lake, but we can't do that. Okay, and when we go through and set up our parameters later, okay, and some future things, we can kind of set this area up to be no data. We're not going to do that for now. Okay, next thing I'm going to set up is my cost distance. So my import or my source, well, we're going to start at the starting point. My cost is going to be this slope right here, okay, that we just went through and calculated. Okay, so this slope map right here. Okay, so that's going to be the cost. That's what I'm going to be buying essentially. And I want to buy as little slope as possible to get from my destination, from my start to my destination. I'll leave all the other parameters the same. And this is going to be my cost distance here. Okay, from my starting point, from this green point right here. And we're going to see what this map looks like here. As you look at this slope map, you can see we don't really want to go up this area here. We don't really want to go up this area right here because it's going to have the highest cost to get here. Okay, even though we want to get from here to here. This is my cost matrix here, and you can start to see what it has here. Okay, we have a little bit. We can travel a little bit further based on that slope cost. Okay, and we look at this, it has a very low slope over here, so we can get a little bit further in this direction as opposed to the other directions. And this just tells us this cost allocation or cost distance from the starting point, and we haven't determined the end point yet. Okay, the next thing we're going to calculate is a backlink, and this is just going to give me the direction, okay, the next cell on the least accumulative path to the nearest source. So this is just going to give me the direction that I'm going to go so I can get from my source to my destination. Okay. In this case, we haven't determined the destination yet. So as we travel along, we're going to figure out the one that has the least cost, the cell that has the least cost. Okay. My starting cell is going to be my start. My cost raster is going to be this slope once again. Okay. And I'm going to click OK. And this is called my backlink. Okay, so you can see what my backlink looks like right here. Okay, so I can see my yellow ones right here. So in the yellow right here, all this means is the one to the right has the least cost. I could go, if I'm in this cell right here, I could go in one of 8 directions. Okay, if it's yellow, it's telling me go to the right in order so I can accumulate as little cost as possible. Okay, and that cost we determine to be slope. You can have this cost be anything. Okay, if we're looking at animal habitat, we make all the forests 1s or 2s and make a roadway to be 100. Okay, it's going to want to travel in the forest in the low cost values as opposed to going over the urban areas or roads. We can have something associated with speed limits. Okay, but keep in mind, speed limits are going to be higher speed limits we want to associate with that, so we want to look at the actual travel time along this, so we can convert maybe a section of road to a travel time that we associate it with. And that cost, we want to minimize that cost as much as possible. So there's lots of different what we call impedances that we can associate with each of these cells. For me, this cell is going to be something quantitative that I just extracted from a DEM, but it can be derived using a reclassify or whatever you want to do. Okay, and when I zoom back out here, I'll zoom right to here. And the last thing I need to do here is compute my cost path. Okay, so my destination is going to be my destination here. I'll leave my destination field the same. Okay, my cost distance, that's the one I went through and calculated before. Okay, my backlink, here's my backlink. Okay, here's my output. And I'm going to go through and run this algorithm using these directions. That'll tell me the least cost distance to go from my start to my destination. Okay, I'm going to check this and check this. Okay, and I'll probably go through and uncheck this here. Okay, and you can see this is the trail that I'm going to build. Okay, this is the path of the trail that I'm going to build where I have the least amount of slope possible to go from my start to my destination. I've run this before and it takes me over the lake, so we have to set these to be no data or just set it to be a really ridiculously high cost. And I can do this running a reclassify or some sort of raster calculation or using actually these as masks or something like that. But I didn't do so in this case here. So you can see the path right here that I run through that. So this is a pretty easy algorithm, very effective. So we can calculate the least amount of cost to go from a starting point to a destination, and we can do different permutations of this. So we can look at circuits and different routes and things like this.